narrow down what we're going to look at in the results. I'll compile my package, or my procedure, which will run my package, and then we'll try it out. So what I'm going to do is run this program 100,000 times. I'm going to look up the data from the employee table for employee 138 100,000 times twice for each different approach. And we'll take a look at the resulting performance. It should take about 4 seconds. The database table lookup, 100,000 queries, took 4 seconds, which is not bad. It's fast for querying. But look at this. Associative array cache, 0.08 seconds to retrieve 100,000 times the data for that employee. This is incredibly fast compared to querying the data. And the reason it's so much faster is that I'm using the cache in my PGA, in the PGA memory, which is explored in a separate lesson on effectively managing your PLSQL applications, how Oracle uses PGA memory. But the point here is that the reason I was able to use PGA memory and the reason my code is so much faster is that I'm using package level data. So I assign the value to that cache, and then when I need to get that data, I don't go back to the database, I simply get it from my cache. And this is the value of persistent data, global data, inside Oracle applications, PLSQL based applications. Package initialization. So your package is initialized in every session in which it's called. And you can specify not only that a specific variable would be assigned a value, but you can even provide a body of code that will run in the initialization section. And the initialization section is a body of code at the bottom of the package that Oracle automatically executes the first time and only the first time the package element is referenced in your session, essentially whenever the package needs to be initialized. So the program will reference something in my package for the first time. And then Oracle says, wait a minute, does the package have an initialization section? And if so, run that code. Afterwards, or if not, then complete the request for the packaged element. In other words, going back to the code here, I ran this code 100,000 times. But the very first time that I ran it, the first time this function was called in the package, Oracle grabbed this code from the database and loaded it into shared memory if it was not already present. Then it instantiated all of my variables and constants at the package level. So climit was assigned the value of 1,000. And then it declared my type, and it declared the variable, it defined the variable based on that type. And then, so that's the first step of initialization. And then it said, wait a minute, I've got an initialization section. It looks like the executable section of a procedure, but with packages it's optional, and it only runs the first time you actually touch the package in your session. And it said, hey, I've got my initialization section, run this code, and run it just once. Load up this cache, and then I'm done. And the next 99,999 times that it ran that code, it did not initialize the package. This code was only run once. So again, when you see code at the bottom of the package between a begin-end clause that's not inside a procedure or a function, that's the initialization code of the package. It's not required, and in fact most packages don't have it, because packages are mostly just collections of code that you want to group together logically. But sometimes you want to perform complex setting of initial values. You want to set up package data which is not going to change for the session. That's the example I just showed you. You might even want to run code to confirm that the package has been properly instantiated. All of these things can be done in that bottom of the package area, that initialization section. Let's talk about the last really important feature of packages, which is subprogram overloading. When you overload programs, you give two or more programs the same name. Now you can overload in any declaration section of any block of code, but usually overloading happens in packages. So going back to that Booch diagram, I can have multiple programs with the same name, myproc, 3 times. Overloading is a critical feature when you're building APIs for other developers to use. In other words, you're writing code that other developers will use to build their applications. And essentially what you're going to do with overloading is make the code as smart and as easy to use as possible. You're going to sit there and think about the different ways that the functionality in your application or this package need to be used. And then you will tailor your different overloadings to fit those different requirements. Essentially what you're doing is transferring the need to know how to use your code from the developer or user of the code to the overloaded program. That's the most general and way that I can describe the value and the importance of overloading. You make your package smarter, anticipating the needs of users of that package. Now, of course, overloading is performed a lot by Oracle. For example, there's a function called toChar, and toChar can be used to convert a date to a string or a number to a string. And if you look inside the standard package, which is one of the building block packages of the entire language of PLSQL, you'll find that there are multiple implementations, both called toChar, each taking a different type of data in. Now, because of that, we just have to know that one name toChar, and if we pass it a date, it does the date conversion. If we pass it a number, it does the number conversion. Without overloading, we'd have to learn about two different program names. Give me the toChar from a date. Give me the toChar from a number. Which makes your API, the number of programs you have to remember and understand and type, larger and more complicated. So in this case, you see the value of overloading providing a very simple approach for me, the user of the PLSQL language. I need to convert something to a string format, and all I have to remember is toChar. Convert it to a character approach, character string approach. And I don't have to remember any of the nuanced or more complex names. So that's an example of overloading inside the Oracle environment. How does overloading work? Well, essentially, for two or more modules to be overloaded, the compiler, the PLSQL compiler, has to be able to distinguish between the two calls at the time code is compiled. What it comes down to is that the signatures or headers of the programs must be different. The way the subprograms are implemented is irrelevant. All Oracle is going to look at is the signature, the name of the program, the type of the program, and the parameter list. And of course, the name of the program only comes into play in that there are multiple programs with the same name. Now, I said that Oracle will distinguish between two overloadings at compile time, and there are two different compile times to keep in mind. The first is when you actually compile the package or the block containing overloaded subprograms. Oracle will check to see if your subprogram overloadings are valid. If they're too similar, Oracle will reject them. Unfortunately, they're very lax about what they consider to be too similar. I'll come back to that. But the most important part is when you try to use the overloaded programs, Oracle will compile them, and at the time of compilation, it will look at your call to your program and the parameters, and it will try to match it to one of the subprograms with the same name. And if it can find a match for that program name, for the type of usage, function, or procedure, and the number and types of parameters, then it will be okay. If it can't figure out which one to use, then it will give you an error. So what does it need to know, or how different do these programs have to be valid overloadings? And essentially, the formal parameters of overloaded modules must differ in number, order, or data type family. In other words, I can have a string, a number, and a date. I can have a string, and a number. I can have one number in one program and a number and date in another program. They have to; those are very, very different scenarios. But notice that they have to differ by data type family. It's usually not enough to have a difference within a data type family. For example, fixed length string versus variable length string is not going to be different enough. And I'll show you an example of that very soon. Also, programs can be of different types. They can have the same exact parameter list, but one can be a procedure and another a function. And that will also be different enough for overloading because they're called very differently in your code. So here are some examples of undistinguishing characteristics. Functions that differ only in the return data type. In other words, one function returns a string, the other function returns a date, but otherwise the name and the parameter list are exactly the same. Oracle will not let you use these overloadings because it can do implicit conversion and they both would look the same. If arguments differ only in their mode, in, out, or in, or out, that's not good enough. And the parameters differ only in data type, and the data types are in the same family, something like car versus varchar2. So here are some examples of invalid overloadings. In this case, I have two different parameters. Well, each overloading, both called calc, have a single parameter, but the data types of the parameters are not different enough. That's ambiguous. What if I have programs that have the same signature except the return type? This is not going to be good enough. It will not be able to tell the difference between these two. And finally, I have a difference in only parameter mode, so in versus in out. again, Oracle will reject this either at the time you create the program or at the time you try to use the program. Oracle will say, sorry, I don't know the difference between these two. I can't decide which one to use. So we'll take a look at examples soon, but the main thing to remember is overload whenever possible. Overloading is a very powerful feature to improve the usability of your code. Developers who use your code, including yourself, will greatly benefit from and appreciate the work you do when you overload. The most common type of overloading is overloading for different data combinations. I pass in a string, I pass in a date, I pass in a number, and the underlying program knows what to do with it. And from the user standpoint, there's just one program that handles all those different types. Classic scenario would be dbms output.putLine. Unfortunately, it's actually not overloaded. It just takes everything and converts it to a string. And if it can't convert to a string, it can't use it. We'll compare that to p.l, my replacement for dbms output.putLine. Another way to think about overloading is fitting the program to the user. There can be different scenarios, different ways that you want to use a program. Sometimes the difference is determined by the different data types of parameters. Sometimes it's the way it's used. Often what I will do is overload a function and a procedure with the same name, because sometimes when I run this program I want to get data back, and sometimes I just want to execute a statement and then not worry about any information coming back. So different patterns of usage result in different overloadings. And then you can take a look at a fairly subtle and sophisticated type of overloading, which is overloading by type and not value. I'm not going to get into an example here, but you could take a look at the dbms SQL package. In fact, let's just pull that up for a moment. Let's take a look at the dbms SQL package, which is the dynamic SQL package, or in PLSQL. And what you'll find in this package is something called column value. Or actually defined column is probably a better example. Whoops. Come back. Sorry about that. Let's bring it back. Back we go to dbms SQL. Can I still search? No, I have to write it again. So here are the defined column programs that are used to define a column in my dynamic query. And there are overloading. So here's multiple defined columns. 1, 2, 3, 4, 5, 6, lots more. And notice they're just called defined column. They pass in the cursor handle, the position in my list, in my select list, and the data type. Notice number, date, blob, bfile, etc., etc. In this case, what's being passed in is the value. It says, what it says here is column, but it's actually the value. In other words, I want to define a column to be of type number or date or string. The value itself doesn't matter. The data type of the value matters. And I have an example here, which you can find out more about in my dynamic SQL series called intab, which essentially displays the contents of a table in PLSQL. And here I define each of my columns. If it's a string, I call define column, and I pass it a string value. If it's a number, I call define column and pass it a number value. So in other words, the only thing that Oracle is using overloading for here is to direct inside the package body, inside dbms SQL, to say, okay, this is a string type column, but it actually doesn't care what the value is. I could pass in A, ABC, whatever I want. The value doesn't matter, just the type. So that's an example of overloading by type and not value. Again, it's unlikely to be the sort of thing that you will ever be doing, but you might find it coming in handy. If you're ever writing code in which you are passing as an argument to your program the type of data that you need to be working with, like put the word string in quotes or number in quotes or date in quotes, then say to yourself, maybe I should just do overloadings in which I pass the value. And if it passes in a date, I perform in the date branch of my code. All right, let's take a look at supporting many data combinations, the P package. Now, I'm sure all of you use the dbms output.putLine subprogram, and it's very handy, but it also has a lot of weaknesses. Here's dbms output.putLine, and I can say display A. I can just say display sysdate. I can say display a number. And Oracle knows what to do when I call it this way, and it displays those three values. Now you might look at this code and say to yourself, oh, so dbms output.putLine is overloaded 3 times. In fact, it's not. There's just one definition of put line, and you have to pass it a piece of data that can be converted implicitly to a string. And if you try to do something else, like display a Boolean, Oracle says, I don't know what you're talking about. Wrong number or type of arguments in call to put line. So it can find a matching procedure with a signature that can be used with a Boolean. And here's the problem with dbms output.putLine. It's not overloaded at all, and it certainly doesn't handle the various types of data that you commonly run into in PLSQL. My feeling is that dbms output.putLine should display whatever I pass to it. It should be able to display strings, numbers, dates, Booleans, blobs, clobs, B files, util files, dynamic SQL cursors, whatever. I should just be able to throw whatever I want at it, and it does the right thing. And that's not how dbms output works. Well, I didn't like that very much. So I decided to create a replacement, and that's called the P package. I also didn't like having to write dbms output.putLine every time I wanted to see something. So I created a package with a funny name, 1 character long, P for put, and L for line, put line. And what I did was create lots of overloadings. Look at all the overloadings of the L procedure. So I can pass in a date, I can pass a format mask, etc. I can pass in a number, I can pass a string, I can pass a string and a number. I can pass a string and a date. I can pass a Boolean, and Oracle knows what to, or my p.l package knows what to do with it. I can pass a string and a Boolean. I can pass it the pointer to a file, and it will display the contents of my file. So what I've done here is actually anticipated the different kinds of things you would want to do when you're displaying. Instead of writing dbms output.putLine string concatenated to date, you would just write instead p.l a comma sysdate. No need to concatenate. In fact, let's finish concatenating. No need to do all that sort of thing. Just say, hey, take my string and date P package and do the right thing. So if you ever find yourself writing code that you find to be cumbersome and excessive, for example, if my Boolean is true, if Boolean, then display true, else display false. If you find yourself writing code like this, you should say to yourself, this is a waste of my time. Why am I doing this? And the answer is you shouldn't be doing it. And instead, you should have your underlying code do it for you. And that's what the P package does. So it takes this kind of logic, puts it inside the package body, and simply lets you pass a Boolean value to it, and it does the right thing. So that's a good example, I think, of comparing minimal or no overloading at all, and providing lots of different data combinations, anticipating user needs, so that it makes it much easier for the user to work with it. In terms of fitting the program to the user, let's take a look at cust rules. Here's an example of, well, this is not an example of different usages of procedure and function. It's just another approach in which I make sure that the user doesn't have to do extra querying. So 2 different functions called eligible for discount. One takes in a record, one takes in the customer ID. And this is something I do a lot in my code. So the first time I need to use the eligible for discount, I have the customer ID. So I pass in the customer ID, I do the query to look up the information, and then I perform the formula. Then I run into another situation where I already have the customer record. I don't want to have to look up the customer ID. So instead what I'm going to do is break it out into 2 different programs. Eligible for discount that accepts a record. Eligible for discount that accepts a customer ID. And then inside my back-end code, my eligible for discount with my customer ID does the lookup and then passes the record to my other function. But if I already have the record, I'm going to avoid having to look up the information again. So this is an example of optimizing performance in your application by overloading in different ways to meet those different scenarios. Do you already have the record? Great. Then pass the record. Do you just have the ID? Pass that to me too, and I know what to do with it. Now, overloading can be very frustrating sometimes because you can get into situations of ambiguous overloading. Let's take a look at that. Here's an example of creating a package which is just too similar to be useful. It's called sales package. I have 2 calc total programs. They each take a single string. Now in this case there is a difference between the two of them. The difference is that the parameter name is different. And Oracle will let me compile this package with no errors. Great. The problem is that in the way that I would usually use this code, which is by simply passing a string to the package program, so calculate the total for zone 15, when I try to use this program it says, well, too many declarations match this call. Stephen, I could call each of the calc totals and pass it zone 15. I don't know which one you want me to use. Now I can get around this problem in this case by using name notation. Because my parameter names are different, I can specify the parameter name and it knows what to do and it displays the zone. But in general, you should never define a package that requires name notation in order to use it. That's a very bad idea. These are simply too similar. Let's take a look at an even worse situation. Here's a package that you might think shouldn't even compile. Same program name, same parameter name, different data types, but they're very similar. And sadly, Oracle will let me compile this code. And the problem here is that I can't use these programs. Here's an example of a package you can compile, but you cannot use. No matter what approach I take, whether I just pass it a string value, whether I pass it a string with the parameter name associated with it, Oracle says, I don't know which one you're talking about. Too many declarations. Too many declarations. In fact, it's even worse than that. I can declare a fixed length variable. And I can pass that fixed length variable and you'd think Oracle would say, well, that's fixed length. This is fixed length. Therefore, obviously, I should use the fixed length version. And still, Oracle says, I don't know what you're talking about. And this has to do with the ability of Oracle to do implicit conversions, changing things from car to var, car2, and so forth, which is really unfortunate. So this is an example of ambiguous overloading. I look at my package definition and I should realize these are too similar. Oracle will not be able to tell the difference. They should be a date and a string, or a date and a number, or a string and a date. But they can't both be different kinds of strings. Now this is a glaring kind of ambiguous overloading, or a more subtle kind of ambiguous overloading can occur when you have parameters with default values. So take a look at this package. My calc total programs have the same names, but different parameter lists. This has 2 parameters, this has 1. Okay, well, Oracle will definitely compile that without any complaints. And in fact, if I try to call it, specifying a string and a date, it knows what to do. So if I pass it this and sysdate, it says no problem. But because one of my overloadings has a default value, the date parameter has a default value, I can leave that value off. And as soon as I do, then I run into ambiguous overloading. So, what you need to do when you're overloading your programs is be very careful about how you're doing the overloading. Look at the overloadings and ask yourself, are these clearly different implementations? Are they going to overlap from the perspective of the Oracle compiler? And if so, make them more clearly distinct. Maybe you shouldn't give default values to those parameters. Make sure that they have to provide a string and a date, and they can't cheat and just pass in a string, leave off the date, and think that everything's going to go right. So as you get into more and more overloading and get more aggressive about it, and I think it's a really good thing to do, you should be very careful to make sure the implementations are very distinct. Okay, drawing some conclusions. You should use packages as the building blocks of your applications. Avoid schema-level procedures and functions. It will make it much easier for you to modularize your code and find all the modules you've written. PLSQL packages offer many valuable features. Session state variables, it's the only way to do this inside PLSQL. Again, not of value in stateless applications, but in many situations, you can take advantage of those session state variables combined with session initialization to get some really nice optimizations of performance in your application. And you can overload at the schema level, well, sorry, it's not really at the schema level, at the package level. So inside your package spec and body, you can have multiple programs with the same name, which means that as other programs at the schema level use this package, they can very easily, the developers can very easily choose between multiple programs of the same name without having to worry about all of the underlying details. It just does the right thing for them. Again, avoid schema level procedures and functions. My feeling is put everything into packages. Even if it's just one procedure. For example, you need to write a function to return a calculation of a mortgage formula, and you say to yourself, it's just one function. Why would I create a package? Well, remember, that's just today. And in the future, you're likely to have to do multiple programs that do very similar things. And at that point, you might say to yourself, oh, now I've got 5 different programs that all calculate mortgage formulas in different ways. I really should put them in a package. Well, then you have to go back to all your function calls and change them to package.function. So start with a package, even if it's a package with a single subprogram, and you will thank yourself later for doing so. Next steps. Well, download the demo zip if you haven't already. Take a look at the various examples of packages, those I reference in this lesson, and also the many, many others that are out there. And I think if you do that, you'll find examples of code you can reuse in your application and lots of lessons about how you can improve the way that you write your own packages. Thanks for joining me. Hopefully you will now use packages even more than